The toughest search and rescue boat ever built takes on any weather, anytime. Virtually unsinkable. Jet engines get planes airborne and keep passengers comfortable at high altitudes by driving vital cabin pressure and the vacuum toilet. This is the power split device in a production hybrid vehicle. Before it was pioneered, cars like this still lived on the drawing board. The redesigned Zeppelin is making a comeback. It looks retro, but this is no history project. Let's take a look inside these machines and see how they work. This is a motor lifeboat, or MLB, a first response search and rescue vessel used by U.S. and Canadian Coast Guards. One of the toughest marine machines in the world, the MLB saves lives in near impossible conditions. It's a 14-meter powerhouse that takes on hurricanes, heavy seas, surf, and winds up to 110 kilometers an hour. And if the boat capsizes, it pops back up again in seconds. It's basically unsinkable. Let's take a closer look. The MLB has a cruising range of about 370 kilometers, a top speed of 45 kilometers an hour, and can tow a vessel 5 times its weight. It's got 4 crew members: the pilot, engineer, and 2 hands, with room for 5 passengers. Its hull is made from marine-grade aluminum that won't rust, is as strong as steel, but a lot lighter. So the MLB can take a 6-meter drop from a wave and slam onto the surface without a dent. But for this boat to save lives, it needs to go fast, so its hull has been molded into a very special shape. To get up to speed, you need a knife-like hull to slice through rough seas and a flat hull to ride high on top of waves. So this machine has what's called a deep V-planing hull, sharp at the front, flatter at the back. Next up, a big power plant and some fighter jet steering to move it through the water. 2 435 horsepower diesel engines drive stainless steel shafts attached to props that need constant maintenance. If these snap off, the rescue's over. The boat's 4 operator stations are controlled from either the enclosed bridge or outside on what's called a flying deck. For maximum control, the MLB uses a fly-by-wire steering system that responds directly to manual inputs and allows for rapid response with little effort. A turn of the wheel is converted to electronic signals that a computer translates into instructions for the boat's rudders. These systems are ideal for machines that work in brutal conditions and have been standard equipment on fighter jets for decades. And like some jets, the MLB can fly upside down. Well, maybe not fly, but it can recover from a flip with the ability to self-right. Thanks to its low center of gravity, the MLB can hold its course at almost 90 degrees. But it can flip. And when it does, there's enough buoyancy in these 5 watertight chambers to right the ship, even if 2 of them get swamped. That's because of the boat's ballast ratio. Basically, air bubbles trapped at the bottom want to rise to the top. The engine's weight and location also help the rolling motion. And there's one more flotation chamber up here, for good measure. Nothing's left to chance. And that's a good thing for crews when an emergency call comes in from the unpredictable Pacific Northwest. Finding victims can be as much of a challenge as getting to them. A spinning direction finder scans for distress beacons. The signal hits the finder's two sensors at slightly different times. The radio direction locator uses this data to plot out where the distress signal is coming from and keep the MLB on target, even if thrown off course by rough seas. On a clear day, finding the victim starts up here on the flying deck. Just an extra 2 meters height buys you a full 4 kilometers of sight. The flying deck's point of view also makes things safer during close recovery of folks in the water. And recessed wells, cut just a few centimeters above sea level, make it easier to pick up waterlogged victims. The MLB's survivor compartment, located in the center of the vessel, helps keep victims stable. It's watertight and climate-controlled to help survivors who may have been injured or submerged in icy waters. There's one other spot that has the potential to flood this ship. Its windows. The enclosed bridge is there to provide a safe, watertight compartment if the crew needs it. But after some extreme testing, it turned out that screw holes in the frame, not the glass, weakened the windows. So they ended up sandwiching acrylic sheets between the aluminum frames beyond the window's edges, spreading the force of the waves over a larger area. The MLB, a powerful machine that's almost indestructible, custom built for the survival of victims and for the safety of its crews. When you're stuck in a plane at 35,000 feet, there are a few things to be thankful for. Jet engines, air pressure, and the vacuum toilet. Jet engines keep us safe and sound, and not just by keeping the plane in the air. They help maintain cabin pressure, and that keeps the toilets working. Let's see how it all works. Jet aircraft use gas turbine engines to get off the ground. A turbofan sucks in air that gets compressed, burnt up in a combustion chamber, and then spins a turbine. The burning jet fuel mixes with oxygen to produce pressurized gas. That's what spins the turbines. And they generate energy in the form of jet exhaust. That has enough thrust to propel the airplane forward, get it safely airborne, and keep it there. But that's just one way the engines play a role during flight. Commercial jets fly at high altitudes because the air is thinner, and that means they get much better fuel efficiency. Good for jets, bad for people. The thin air means less pressure and a lot less oxygen. So how do the engines help? Each engine sucks in over 1,000 kilos of air per second to propel the plane forward. 20% of that air is captured and redirected into the plane. But you can't just go blowing that into the cabin. At this point, it's hot enough to roast a chicken. So, rams on the plane's belly take in the ice-cold, high-altitude air. The two streams are mixed, temperature is adjusted, and then it's forced into the cabin to create pressure. A butterfly valve regulates the amount of pressure inside the plane. If it gets too high, the valve releases air automatically. And despite what movies tell you, these doors cannot be opened when you're high in the sky. Air pressure locks them in place once these edges seal the door to the inside of the fuselage. At 35,000 feet, with cabin pressure 4 times higher than what's outside, passengers are kept alive and comfortable. But not that comfortable, unless this is working. Imagine crossing the Atlantic without one. So what's the engine got to do with that? First, here's a gravity toilet found in your home. When it's flushed, water from the tank fills the bowl. It moves into the U of the mechanism. This creates a siphon that pulls everything down the drain. A water and gravity flushing system's not an option on an airplane. Too big, too heavy, uses too much water. So engineers turn to vacuums to solve the problem. And this is where the jet engine and the cabin pressure it produces comes in. When you flush a toilet on an airplane, there's a loud rush of air. And as long as you hold down the button, it keeps on sucking. That's why the airplane toilet is called an active vacuum system. High-pressure air in the cabin is always looking to escape to the low-pressure air outside the plane. So it's harnessed with every flush. Flushing opens a valve that sucks high-pressure air from the cabin with waste material into a septic tank. The tank lives in the unpressurized belly of the plane. A vacuum is created by the difference in pressure between the toilet and the valve. The septic tanks are emptied when the planes are back on the ground. Despite a few myths out there, waste doesn't get launched into the blue. The only thing coming out of here is air. And despite all that pressure sucking the inside of the bowl, there's no chance of getting stuck on the rim if you flush while sitting down. The seat design allows air to circulate through these openings and prevent a seal from forming. The vacuum toilet is highly efficient, just 1 liter per flush on some models. Our toilets at home use up to 6 liters for each one. And if you've ever been stuck on the tarmac for a couple of hours, you'll appreciate this little add-on device. It's called a vacuum generator. On the ground, the air pressure inside and outside the plane is identical. There's no natural vacuum. That doesn't kick in until the plane passes the 16,000-foot mark. No bigger than a 2-liter bottle, this generator is a powerful version of a home vacuum. Using a fan, it sucks air from one end and blows it out the other, keeping the call of nature at bay until air pressure kicks in. The jet engine spawned a travel revolution, allowing us to fly around the world non-stop for up to 18 hours while keeping us breathing and comfortable. This is a gas-electric hybrid car. The idea behind this machine is to increase fuel mileage and reduce emissions of a gas-powered car while overcoming the long-distance limitations of an electric car. Looks like a regular ride, but peek inside and you'll find new parts and innovations that made the whole idea possible. Let's see how it works. When it comes to vehicles, hybrid simply means using 2 or more distinct power sources to create motion. There are lots of different types of automotive hybrids out there, but the most common ones are called parallel hybrids. That's where the 2 power sources work alone or together, side by side, or parallel to each other. The big challenge for engineers? Produce a gas miser that gets to highway speed as fast as any big guzzler, with only a tiny engine, an electric motor, and a big set of batteries to turn the wheels. But to do that, engineers had to figure out how to get the gas and electric motors to work together to maximize fuel efficiency. Then, keep the batteries charged so you never have to plug them in. It takes about 200 kilograms of batteries to store as much energy as 1 liter of gasoline. So, until the technology radically improves, we're going to be using some form of fuel-powered engines in our cars. There are 2 things that dogged hybrid car makers when it came to balancing fuel economy with performance. A small gas engine is really efficient when cruising at a fixed speed, but it lacks kick on acceleration. An electric motor gives instant pickup off the mark, but dies soon after. Hybrid makers wanted both, so they dreamt up a clever device that makes the electric motor, gas engine, and battery charger talk to each other. It's called a power split device, the real brains behind this pioneering hybrid. A set of gears drive a chain that's connected to the axle that drives the car's wheels. It's the delicate interplay between the gears that determines how much fuel you burn. When you first start rolling, the electric motor spins this outer gear. And that gets you up to speed without wasting a drop of gas. Perfect for the stop and start of day-to-day driving. But you wouldn't want to hit the highway on batteries alone. Electric cars only go a couple hundred kilometers before they need a recharge. So once you get up to speed, the gas engine kicks in. It all happens through the power splitter. These 4 planetary gears start to spin, boosting the car's power. This center gear also goes into action. It's connected to a generator that either charges the batteries or sends extra power to the electric motor. It's so smooth, the driver doesn't feel a thing. The only sign of change is on the monitor that lets you know which power source is working. You're now burning gas at peak efficiency and charging the batteries, never having to compromise power. When it's time to pass a slowpoke, the electric motor has enough juice to fire up again and add power to the gas engine. So even when you hit the gas, you don't waste any. The hybrid's computer keeps track of power consumption and sends ongoing commands to the power splitter. It stops the gas engine when you don't need it and starts it again when you do. It even kicks it into a battery charging idle if it senses your system is getting dangerously low. The electric hybrid's power split device opened the floodgates on innovation. This machine marks a turning point in automotive engineering that's giving drivers what they want. A powerful yet low-cost ride that goes a long way. This is the Zeppelin NT, an airship whose roots go back to the 1890s. The old-style Zeppelin is infamous for this, but that's ancient history. New high-strength fabrics, lightweight aircraft composite materials, and computer-guided systems have revolutionized the airship. Longer than a 747, but a fraction of its weight, the Zeppelin is back, hoping for a future moving people and cargo. And that's not hot air. The helium-filled NT stands for New Technology, vectored props, digital joysticks, and 3 aircraft engines. This machine cracks highway speeds while cruising at altitudes above 8,000 feet. And it can stay in the air twice as long as a commercial airliner. Let's see how it works. The NT gets its lift from helium gas. Older generation airships were filled with much cheaper hydrogen, but they were a little volatile. Modern Zeppelins use helium, a noble or non-reactive gas, highly stable, almost as buoyant as hydrogen, but very expensive. That's why the NT's outer skin is made to prevent leakage. And that's tricky, because helium molecules are extremely small. A party balloon loses its lift over time because the helium literally escapes through the skin. Airships need a much tighter helium barrier. So the NT is clad with a material woven tight enough to contain most of the helium. And this machine needs a lot of it. In order to go up, it has to hold enough gas to help its engines overcome gravity. About 1 cubic meter of helium gives you 1 kilogram of lift. The NT holds about 8,000 cubic meters of helium, so it should be limited to lifting about the same weight. But it can lift close to 10,000. How does that work? The NT is technically not lighter than air. So unlike its predecessors that always wanted to float away, the NT can be made to sink. This makes loading and unloading people a lot simpler. But how do you fly a floating machine that's heavier than air? To rise up, the NT needs thrust and power from 3 200-horsepower engines. 2 are mounted on the side of the hull. The third is mounted at the rear. They power variable pitch propellers. Rotate them up, hit the gas, and away you go. The rear engine also controls a second fixed propeller that helps move the machine from side to side. During boarding, the airship is in control, held in place by the engines while passengers get on and off. And its final takeoff mass is adjusted by a water ballast system that can add or take off weight depending on how many passengers have climbed aboard. Once airborne, the propellers rotate again to provide thrust and propel the airship forward. The 3 engines give the ship a tight turning radius, with a computer-controlled steering system wired to the pilot's joystick. And that means instant response to changing conditions, maneuvering like a helicopter, hovering, moving sideways, or turning on a dime. But this isn't just a motorized airbag. A highly engineered skeleton holds it all together. The Zeppelin's gondola, rudders, fins, and stabilizers are all mounted to triangular graphite frames. Aluminum girders connect them along the length of the ship, and it's all held together by super strong cables. The NT's internal structure allows for bigger engines and bigger loads. There is one problem the Zeppelin has to solve in managing its helium. As you rise in the atmosphere, air gets thinner and helium expands. The opposite happens as you descend. Air expands and helium contracts. Both situations affect your ability to stay airborne. So the NT uses air-filled ballonets to keep air and helium balanced. They maintain the hull's perfect shape by increasing or decreasing the amount of air pressure inside it. The ballonets release air as the airship rises and pump outside air in as the machine comes down. That takes care of flying. So how do you land this thing? Because the NT is heavier than air, the pilot just has to ease off the engines and change the pitch on the props to gently set her down. Once landed, the airship is locked onto a 20-ton mobile hydraulic mast. Even in high winds, the mast allows the ship to turn a full 360. The newly minted Zeppelin won't set any airspeed records, and you may opt for an airplane for rush delivery. But for cheap, efficient lifting and a fun way to fly, the NT may have found its niche.